now I'm super happy to hand over to Dave McComb. The story was very funny. I didn't know that Dave was at Semantics at Roche, so I didn't even consider asking him because he comes a long way. And then Dave wrote me like, hey, I see you are in Basel, so am I. Should I do a presentation? And I said, hell yes. So Dave, your stage.
Great, thank you. So Adrian asked me to do a case study, and we want some lessons learned, we want some success, we want some failure, good guys, bad guys, you know, storytelling, all that. So I guess that's what I'm going to do. But I also have a theme to this, and in fact, if you want to get the gist of this next presentation, by the way, the gist is a pitch for our upper ontology, but if you want to get the gist of what I'm about to talk to you, you can just write down this one sentence. In fact, you can write down this one sentence and then go take a nap for 20 minutes because all I'm going to do is tell stories about it. The one sentence is, simplicity is the gift that keeps giving. That's all I'm going to talk about for the next 20 minutes. So here we go. So this case study was with Schneider Electric. They're just down the road here in Grenoble, France. They make, as many of you guys know, about 1 million different industrial electric products. And they're complicated. Every one of these little things, relays and circuit breakers and stuff, have dozens and dozens, often hundreds of physical and electrical characteristics, and adheres to standards or doesn't, and operating characteristics, all kinds of stuff, as you might imagine. And it's kind of dangerous stuff. A lot of these things are 10,000 volts and all, high current and all this, and if you put them in the wrong place or do something wrong, buildings burn down, people die. It's kind of serious. And they had they had an existing product database, moderately complex. This is just a little piece of it, but it had about, if I remember correctly, 700 tables and around 7,000 attributes, which was keeping track of all those electrical and physical properties and specs and uses and also prices and what country was it being offered in and what specials and what was it bundled with and all that stuff that you might imagine. And they had this intuition that if they took all this data and put it in a graph, maybe they could make some of the rest of their life simpler. In particular, we're going to talk about product compatibility, because that's a big deal. So we took this. Yeah, they wanted to work on compatibility, this is not one of their products, but most of their things, if you look at them, you have no idea whether two things are compatible or not. They're just these weird gray boxes that maybe you should or shouldn't put them in circuit together. So anyhow, we designed an ontology, of course, and it was based on GIST, and it had somewhere in the order of 150 classes, 150 properties, something like that. As those of you who were here yesterday, I talked a little bit about this idea of having an enterprise ontology so that everything you do sort of fits into a bigger pattern, but it doesn't have to be super detailed. And then, we did, as most of you would do, we just took their data, R2RML. In fact, it was Capcenta, I think, if I remember correctly, put in a triple store conforming to the ontology. That's a pretty straightforward thing to do. What's kind of fun and what Aura suggested an hour or two ago is what's sort of interesting about a knowledge graph is it is sort of self-discoverable after the fact. You put stuff in, you run a query and say, gee, what did I put in there? Actually, because it's not quite as premeditated. I mean, obviously there is some premeditation. You don't just accidentally do this, but you design the sub-ontology and you do some sparkling and tarkling and stuff and get the data in there, and then you go, oh, wonder what we have. We have, here I was just counting, triple patterns, class plus a predicate. What did we end up doing? A lot of specifications and parts and scopes, nothing terribly surprising there. What predicates did we use the most? And there was there's 10 million types, so we must have had 10 million objects to represent these million or so products. So, and it was not till we didn't even go in intending to simplify this thing. You just load it all up, and you count, you say, well, it looks like, in fact, I like to do this for non-semantic people. Say we ended up with 46 classes and 36 properties. So people that work with tables go, what are properties? You mean like attributes? Yeah, like attributes. So how do you have fewer attributes than tables? That's one of those things just to mess with relational people's heads. If you want to do that, and it doesn't even have to be numerically very much less. If it's even one less, they go, wait a minute, you have less than one column per table? That's kind of weird. But as you know, properties reusable, so you just reuse them. You saw the list there, we used them a lot. And then if you compare it to what they had, that's about almost 2 orders of magnitude, not quite 2 orders of magnitude complexity reduction. And there's two things to that. The first one is I'm always puzzled, because we were partnered with another firm that was rebuilding their website, and it had not only all the characteristics and all that kind of stuff, but the pictures and the CAD files, because we picked up everything, and the prices. So there wasn't anything missing. It's not like that was a lossy, and in fact, not only the same amount of information, same fidelity, same precision, same everything. So there's two things that often puzzle me. The main one is, what is all that extra crap? It's like 98% crap and 2% good stuff hidden in there. And I still, most of the time, can't figure out. And almost all systems, many are not quite that extreme, but God, it's amazing. If you look in and find what's the essence of what's going on there and what's everything else that's accidental. And the other, as we're going to get to, is what a bonus it is to only have to deal with 82 concepts. In fact, we were telling this to one of our other clients at one point. We were more talking at the couple of hundred concept level, and this was a business person, and he said, yeah, that's kind of at the level that a motivated analyst could learn over the weekend. And you go, yeah, that's the whole point. We want to get it down, not only be numerically simple, but expressed in plain English and normal words and business terms and all that kind of stuff. Instead of, a motivated analyst, if you have to deal with hundreds of tables that you have to join yourselves and know what, that's a lot of work. So that's what we're trying to get past. So now let's talk about what you get. So some people say, okay, so you simplified it, big deal, who cares? The first thing they asked, there was some spec that I'd never heard of called ETIM. I don't know what it is. It's just a different way of displaying the characteristics of electric products. It didn't happen to align with the way they designed their existing system. So this has been a problem for them for a long time. They said, could you create the ETIM spec version of our products? And it turned out this was so simple, I'd even forgot we did it. I just went back in our files and went, oh yeah, that's kind of cool, whatever that is. That didn't, because you just stare at, 46 classes and 36 properties, and where do they go, and how do I line them up? Some of these are categories, but, Then they said, okay, how about this then? There's this spec called E-class. It's an industry standard and it just covers electrical products. That's the E and E-class. They said, oh yeah, a lot of our clients want to know where do we fit in this whole E-class thing. Well, it turns out E-class has 10,000 classes. Oh God. It's sort of hard going from 700 tables and 7,000 attributes to 10, and you go, yeah, but it turned out, instead, if you look through the other end of the telescope, you go, hey, wait a minute. I have to find, where do these 46 classes and 36 properties end up in here? And it turns out most of the classes are categories in our thing, so they're little tags. You have to align them. You have to figure out where they are. But again, it turns out not a huge amount of work. A few months' work, if I remember correctly. Then they acquired a company in Australia called Clipsal. It's now by Schneider. And they said, oh, you think you could bring their product catalog into ours? And theirs was residential electrical products. So things like, light switches and plugs and stuff that you'd find in your house. And we said, yeah, probably. And they, of course, had a catalog. And it was not as complex as Schneider's, but it was complex and all kinds of arbitrary, strange stuff. But we went, well, armed with, we just got to find out these 46 classes and 36 classes and 46 classes, 36 properties. Where are they in that? And we just talked to them. Where would I find this? Where did I find? Oh, it's here. And you just do a little query to get the stuff out. And then we got all that out. We then said, now, is there anything else in your database that we didn't pick up that's important? And I thought about it for a while. Yeah, we have this thing called aesthetic groups. It turns out in the world of residential electric, people care, that little plate that goes over your light switch, they care whether it's ivory or ecru or bone or off-white or something like that. Industrial electric designer, they don't care. It's just white. Okay, what are the aesthetic groups? In you go, and we assign aesthetic groups. And you can put it right in the same database query. You could even find somehow they had some of the same products. I think this is a slide from one of their internal things we're trying to work out. You get in the middle of these things, you go, oh, yeah, wait a minute. Which ones are the same, and which ones can't we figure out? I don't remember what we were doing there. But anyway, the other thing, though, that was comical about this one, so we do this, takes, 6 or 8 weeks, and then we happen to be in Wikipedia for some other reason, just looking at Schneider, and then said, wait a minute, you acquired them 10 years ago. Why didn't you do this in the last 10 years? Well, it was too hard. So that's kind of what did work. There's some success stories here and some reasons for trying to have simplicity. But, lessons learned, I guess, are more fun when you get into what didn't work and what you learned from that. So the essence of the problem, or where we got started, so I sort of did the side paths of what we did along the way, and they just ask, oh, do this. But the compatibility problem kind of works like this. They're very country driven. So somebody's running a country like Austria, they get to decide what parts are sold. And by the way, they give them new numbers and rename them and change the spec ever so slightly, because the exact same product coming out of the factory, if you sell it in Germany, it's cheaper than Austria, or a bunch of examples like that. So they don't want anybody to know that it's the same. The Austrian product manager doesn't want anyone to know. So they not only change the number, but most people would be clever. They could nowadays run LLM or something and figure out, oh, the specs are the same. It's probably the same. So they change the specs, not in any way that would harm anyone. You can change the operating temperature range and just make it narrower. That's not going to harm anybody, but it's also going to suggest just mechanically that it's not identical spec. So they do a lot of that. And then, and they only sell a subset of all products in a given country, and they're always having offers and prices and all that. And what happens is the parent company makes a new bunch of products, and the country manager says, oh yeah, I think I'll start offering those. So they download some candidate products. Maybe they're brand new, or maybe they're couple of years old, but they finally decide, yeah, I think that could be popular here in our country. So they download them and put them in this giant spreadsheet that has all kinds of weird formulas and multi-tabs, and where an engineer sits down and tries to figure out what is this compatible with that we were already selling in this country. And we went through this 2 or 3 times, very complicated, and then you have to convert it one more time into yet another weird format to go into SAP, because that's where they sell these things, and SAP wants sort of the final word on, are these products really compatible? And I mean, I'm not quite sure what they would do if somebody put an incompatible product in their shopping cart. I mean, maybe they're buying 2 different things. It's weird to me that SAP would be figuring that out again, but anyway, they do. So that's the process. And we had this idea, I don't know if you recall back to the layer cake, talked about that a little bit earlier. For a long time, and Nora was saying the top part of the layer cake never got done. This rules thing has always been a bit dodgy. For a long time, it just said the word rules. Then for a very brief time, it said swirl. But at the moment we did this project, it said riff. I guess it still does say riff, but this is probably the only project I've ever heard of that ever used riff, rule interchange format. So we decided this sounded like a rules problem, compatibility and all that kind of stuff. And we brought in a subcontractor that was an expert in this. At the time, there weren't very many experts in this. Okay, let's do this. We've got all the data's now in the triple store, go. And this was an internal page from Schneider. They were doing an internal readout. That was their opinion of this project. Failure. Oh, God. Can you imagine that's your project and your client is having a readout to their boss? Yeah, that was screwed up. And it's screwed up at, I think, 2 levels. One, I don't really think the tools and everything else were up for the job. But I think more importantly, the contractors we had tried to look at those spreadsheets and recreate exactly what they were doing. And it was this really convoluted mess of what they were doing. And I thought we were going to get kicked out, but we didn't. Our sponsor said, let's rethink this. Maybe there's another way to do this. And it turned out we just went and talked to people who, because we were in Grenoble, just talked to people who design these products. And ask those sort of silly open-ended questions that you can get away with if you don't know anything. So what is it that makes products compatible anyway? And they would just tell us. We go through several of these interviews, and finally we figured out, there was, some are dead obvious once you say it. There's electrical properties of voltage and current, and they're in range, and okay. And then there's some things that has to sit on a given rail, and then there's some other much more subtle ones. I don't know if the one I had up there, they have these toggles, and if you put too many of the toggles together, after a lot of testing and in those little things with robotic arms that lift toggles up and down, they realize they had some weird combos of these devices. And you just kind of have to enumerate them after a while and say, okay, that's it. And it turns out there's maybe 20 or 30, I don't even remember the exact number, but it was a very finite number of rules that you could just we ended up writing in Sparkle insert queries. So you just run it, jam it back in the triple store to say, essentially, these products are intrinsically compatible. We're just sitting there in a triple store such that when you do go to download it in country, you just say, oh, it's compatible with this product I already have here. I mean, it's just one triple. I mean, this stuff is so simple sometimes, and we make it so hard. So yeah, that was surviving from that. The other kind of lesson learned, somewhere around that time, I think, I put out this idea. I said, the nature of our work is disruption and change and transformation, all that kind of stuff, because we're out there. the organization doesn't want to change in general, but somebody in the organization wants them to change. That's the interesting dynamic. And right about that time, I was telling our biz dev guys, I said, what we need is a product champion who believes in this so much they'd bet their career on it. I thought, we're trying to figure out exactly what are we looking for here. And that's what we found at Schneider. And of course, I found it again more obviously. I'll tell you about the more obvious one later. But the corporate antibodies got our sponsor. And they get ejected pretty rapidly, and you very often don't. And then project's over, gone. You got no backup. So there's a lesson learned there. The other one, and the coin didn't drop for me at that moment. The coin dropped several years later, working with a small or medium-sized, I guess, networking firm. Had another one. We want to find the change agent who's willing to bet their career that this is the right thing to do. Found this guy, promoted us in a project and got it all internally sold, and somehow managed to get us paid before the project even started, which we thought, that's pretty incredible. That almost never happens. And then that got him fired. So this time our sponsor was gone even before the project started. So this is December, right at the end of the year, he wanted the money spent out of this year's budget. Boom, he succeeded at that and then got ejected. And we didn't know anybody at the company. And all of a sudden, it took us A, we didn't want to give the money back, but B, we didn't want to just keep it. We wanted to actually do the project. It took us about 6 months to get another sponsor, get the thing spun back up again. But that was when I finally realized, no, that target was too extreme. I think what we're now looking for is someone who wants to become indispensable to their company. So hopefully, I know that's kind of a subtle distinction between somebody who's willing to bet their career that this is the right thing versus someone who wants to become indispensable, but we're hoping that indispensable people stick around, So here it is, if you, like I said at the beginning, if you take nothing else away from this, simplicity is the gift that keeps on giving. I mean, I see this over and over and over. I can't stress it enough. I don't understand why people make things unnecessarily complicated, but they do. Because the main reason is just reducing complexity makes everything else you want to do easier. Simple as that sounds, it's not easy, it's just simple. Your success is never guaranteed, and I suppose the other lesson is, whether you're an outsider like we are or an insider, insiders need sponsors too. Most people want to do this, don't have the access to the resources to do it. Therefore, I think internal people can learn something sometimes from external people, which is, you have to find and cultivate a sponsor or else nothing's going to happen. So that's it. I got plenty of time for, is that timer for the talk or for the talk plus the questions? I don't know. Lost. Oh, okay, I got time for questions. Thank you. There's one.
Thanks so much, Dave, for highlighting the wider context, right? This is not about ontology, our technology, right? As Ora already said, so the business context needs to be considered, and the human context, of course, the human factor. Sponsor,
right?
Okay, have an entry door, right? Plus, it is disruptive because people are not going to give up their responsibilities, right? So you need to deal with human beings. And what I learned, of course, you need to potentially change the perception within the company, right? Mm-hmm. So this is not disruptive. This is not just going to cost your job. Potentially redefine your position and make you co-owner of a solution which is wider than what you were looking at. right? So this is exactly the point where the technology, which is unifying data across the enterprise, is much disruptive, and you definitely need to tackle and cover the human factor, and as I said, change the perception and the culture within the company. Thanks so much.
Yeah. Right on. You just reminded me, we had an internal session recently, and I was thinking about those exact ideas. I ended up drawing 9 little chevrons each, had 4 chevrons each, and then arranged them in this star. It looked sort of beautiful, but like this 9-pointed star. But it was about trying to remind our people that we have to change an organization on about 9 different dimensions in parallel. And sometimes, some of it's the obvious stuff that we know and that we like, the data definition and the data organization, but it's the technology stack, but it's especially the culture and the organization and training and a lot of these soft things that we sometimes forget that, you really have to bring the whole thing along or it's going to fall.
Okay. Yeah. Sorry? Okay.
Yep.
Thanks, Dave, for these practical lessons. You mentioned that the rules were not able to compute compatibility. That was one of the failures.
Yeah.
Could you elaborate on this? What the Sparkle update rules could do, what the Riff rules weren't able to do? Because we did a very similar thing with electric compatibility computation with the company, and I see advantages of rules in contrast to Sparkle update queries in terms of termination, explainability, and all that stuff.
Yep. Yeah. So the question was, what was it that rules couldn't do? There was 2 things. One, this particular tool required that you have everything in memory, in the memory of this tool. So it wasn't interrogating a knowledge graph. It was give me a whole copy, and it was sort of memory limited the way it put together. So the first problem they had was a performance one. The second problem they had, it wasn't very set up to be a multi-user thing, which is also a problem. They wanted hundreds of thousands of users. But the third thing, where it really killed it, was they literally tried to redo what people were doing in spreadsheets. And that just didn't pan out. It was too odd and complex. Probably what you guys did as well, when you step back and say, what is it fundamentally that makes electrical products compatible? It isn't really that hard. And if we had a different, after we learned what we had to do, we probably could have done it in Riff. But by this point, we'd already done it in Spark, and we said, that's fine. But I think, you could do it in Datalog. I think it's just if then else logic. If this part's range of amperage is within this, then, none of it was hard, really.